Continuing my rebuild of the Z80 game Caverns, never released on the ZX81. In this video I'm going to look at the CPDR Z80 instruction and look at how it can be used to improve performance. The instruction repeats the CPD instruction until either BC is 0 or the contents of the HL register is the same as what's in A. And CPD runs multiple instructions comparing A to what's in the memory pointed to by HL, decrementing HL and decrementing BC. So what this allows you to do is scan over areas of memory looking for a certain character which is in the A register. So going back to my Caverns game, I've been rebuilding this first of all using the Spectrum Next, and most of the videos I've been making about this recently have been about the Next. In parallel I'm also working on a version of the game to run on the ZX81 itself, so it can be run on the original platform. Writing the code first on the Next and then converting it to work on the ZX81, which uses the same Z80 processor. So going back to where I last got to 3 years ago with the ZX81 version, I've got the menu screens displaying, the intro screens displaying, and you can start the game on a chosen sheet. So here I've got sheet 5 displaying, and you can see the lifts are running very quickly. And I'd also got the blocks dropping and the icicles dropping. So this is the game running with the icicles dropping. You can see them dropping here. These blocks would also be dropping. And the reason it's so slow is because it scans through each memory location in the display. And this is, on the ZX81, this is quite slow. On the Next it's much faster, so I don't really have a problem with that. So going back to when I first wrote the game, I used the CPDR instruction to make this part of the game run a lot faster. So in this session I'm going to look at optimizing the code using the CPDR instruction to do what I did previously. So the game on the ZX81 is very close to the game on the Next. So I've got a game loop, and this originally called drop blocks, called drop icicles, activated the icicles, move the lifts, and so on. So what I'm doing is I'm going to replace this original call drop blocks with a new call drop blocks CDPR, and do the same thing for the icicles. So going into drop blocks, up at the top of the file I've got the original code, and then lower down here I've got drop blocks using CPDR. So this is my entry point, drop block CDPR, and then so what this does is it looks at the display, working up from the bottom, looking for any blocks that might be able to drop either into space or onto a dual character. So this instruction here gets the top of the display memory, and then I'm adding on a number of rows to get the bottom end of the screen. And in BC I load in how many characters I want to check, so that'll be about 21 rows going up the screen. And the character that I'm looking for is the inverse X character, which is the block character. So working up from the bottom of the screen and then dropping down any blocks that have got anything below them that they can drop onto. So here you've got the CPDR instruction, and that starts at the bottom of the screen and works up, and it'll drop out of the instruction if it comes to a block character or it gets to the top of the screen, i.e. BC has got to 0. So if it reaches a block character, it drops through to check drop block down here, and then in that it checks here whether there's anything below, like a space that it can drop into or a dual that it can drop into. And if it gets either of those, it then drops onto that space. So here the 189 character is being loaded into HL, which is on the line below where it was before. And here I'm clearing A, put that into the opposition where the block was before. Then it just loops back around until it's done the whole of the screen, all the blocks on the screen. So it's a fairly simple function, really just scanning through the display a bit more quickly than it did before, and dropping the blocks down. And then I've done the same thing for the icicles, so pretty much copied the code, except instead of the inverse X block character, it's looking at the normal X and doing the same thing. So if there's a blank space below, or if there's a dual below, the X will drop down into that space. So going back to my loop, I've commented out the old drop blocks and put in the new drop blocks with the CPDR, and done the same for the icicles. So if I then load in that version, into the 81 emulator, and then run the program, start it off. So this is sheet 2. You can see, you saw the block character dropping down from the top here. You can see the icicle X characters dropping down across the screen. You see that the lift is running very quickly. So we don't have a performance issue anymore by scanning all these blocks. So the other thing to do is so because it's much quicker, I now need to add a delay in. So if I add a delay, and then run that, and you can see that the lift is now moving at a more reasonable speed, still probably a bit too quickly, but I can play around with that. So I'm using the 81 emulator to run the program, and I'm using Flat Assembler to compile the assembler code. So you basically navigate to your main assembler file, which is caverns.asm, and then compile. That's quite simple. If you've got like a syntax error, and then suppose I try and compile that, it tells me that I've got an illegal instruction, and I can sort that out. One thing to watch out for is if you've got an illegal instruction in like a sub file, like so. It'll tell you where it is in the Dropbox file. But then if you want to compile, you've got to remember to go back to the original file. So I remember being very impressed by the CPDR instruction when I first learned Z80 programming as a teenager. It seemed like a bit of a miracle instruction. And I still think it's quite a cool instruction. So I hope you found this interesting. Thanks for watching.